Okay, so part two of solving quadratic equation discusses the square root property. So remember, when using the square root property, or the form it's supposed to look like, so that we can use the square root property, is this form. You'll look something like an algebraic expression containing the variable squared equal a non-zero number. So let's say this non-zero number is d. So some kind of real number other than 0. All right, once it's at that form, so remember something squared equal a number. That's probably how you remembered it from last semester. So some algebraic expression squared equal a number. So once it's in that form, you want to get that algebraic expression by itself. So right now I'm squaring this algebraic expression. The opposite of squaring is to take the square root. So remember, when you took the square root of both sides, remember you had a plus or minus. So then the square and the square root undo each other. So you get u equal plus or minus the square root of d. So that's how you got this algebraic expression by itself. All right, so this is how it's going to look. So let's say you want to solve these quadratic equations. So number one, let's suppose we had 3x squared plus 2. 3x plus 2 squared equal 9. So notice it looks like this. It's of that form. So some algebraic expression squared equal a non-zero number. So that's 9. Okay, so the next step is to take the square root of both sides. So let me just go ahead and rewrite this over. So I take the square root of both sides. So remember though, you're going to get plus or minus. All right, plus or minus. And then the square and the square root undo each other. So you get 3x plus 2 equals plus or minus. And then you should all know by now that the square root of 9 is 3. So you get plus or minus 3. Now notice that this, when I took the square root of 9, that this became a rational number. So once this became a rational number, what we did next was we kind of wrote it out as two separate equations. So I got 3x plus 2 equal 3, and then 3x plus 2 equals a negative 3. And then I solved each of these individual linear equations. So subtract 2 from both sides, combine like terms. I get 3x equal 1, so x is 1/3. There's your first one. Over here, subtract 2 from both sides, combine like terms. Negative 2 and a positive 2 is 0. 3x equals a negative 3 and a negative 2 is a negative 5. Dividing both sides by 3, because right now I'm multiplying both sides. I'm multiplying x by 3, so the opposite of multiplying is to divide. What you do to one side, you do to the other. Reduce. 3 divided by 3 is 1. 1 times x is x, and so I get negative 5/3. So your solutions are 1/3, comma, negative 5/3. All right, number 2. Now remember, we split it apart. If you need to go back to your previous course, we split it apart because this right here, these were going to be rational solutions. Okay, rational solutions. So notice I ended up with solutions being rational numbers. That's what that means. All right, number 2. Okay, suppose we had 5x minus 1 squared equal 7. So 5x minus 1 squared equals 7. So it looks like the previous one. It looks just like number 1. It's of that form. So some expression squared equal a number. So I'm going to take the square root of both sides. Let me go ahead and rewrite this over. So square root of both sides. What I do to one side, I do to the other. But remember, this is going to be plus or minus. So the square and the square root undo each other. So I get 5x minus 1 equals plus or minus the square root of 7. Now notice in the previous problem, 9 was a perfect square. So the square root of a 9 is 3, which is a rational number. And so here, 7 is not a perfect square. So I'm going to leave it as the square root of 7. And so remember, since this is going to be irrational now, so these are going to be irrational solutions. All right, so rational versus irrational. So square root of 7 is an irrational number. Okay, so since these would be irrational solutions, then all you do is write it in compact form. So leave it as plus or minus square root of 7. So I'm going to add 1 to both sides, combine like terms. 1 and negative 1 is 0. So 5x equal, now be careful, this is 1 plus or minus square root of 7. 1 plus or minus square root of 7, that's what that is. 1 plus or minus square root of 7. And to get the variable x by itself, right now I'm multiplying by 5. The opposite is 2 divided by 5. And so I get 5 divided by 5 is 1. 1 times x is x. 1 plus or minus square root of 7 divided by 5. And so there's your answer. So in compact form. Now another way to write this, though, on my math lab, they're probably going to ask you to write it as two separate solutions, or two solutions separated by commas. So you would say 1 plus the square root of 7 divided by 5, comma, 1 minus the square root of 7 divided by 5. Okay? You could also write it as two separate, each one as two fractions. So 1/5 plus the square root of 7 over 5, comma, 1/5 minus the square root of 7 over 5. So 1 divided by 5 plus square root of 7 over 5. 1 divided by 5 minus square root of 7 divided by 5. All right, so it's number 2. All right, number 3. Suppose we had 3x minus 4 squared equal 8. So 3x minus 4 squared equal 8. Now remember, it's still in that form. Some expression squared equal a number. So I'm going to take the square root of both sides. Take the square root of both sides. Don't forget plus and minus, though. So the square and the square root undo each other. So you're left with this expression, 3x minus 4 equal plus or minus square root of 8. All right, now notice 8 is not a perfect square, but I can simplify the square root of 8. So remember, in the previous course, how you simplify radicals or square roots in this case. So the perfect square that goes into 8 besides 1 is 4. So that's 4 times 2. And remember, you wrote this as square root of 4 times square root of 2. So the square root of a product is a product of the square roots. And then the square root of 4 is 2. So you get 2 square root of 2. So the square root of 8 is 2 square root of 2, and that's what goes here. So 3x minus 4 equals plus or minus 2 square root of 2. So the directions will also say make sure you simplify. So you have to do that. Now, just like over here, once I got this, then remember you got to get the variable x by itself. So I added 1 to both sides, and ended up with, for here, I ended up with 1 plus or minus square root of 7. So again, same thing here. I'm going to add 4 to both sides. Combine like terms, I get 3x equal 4 plus or minus 2 square root of 2. All right, and then next step is to get the variable x by itself. So right now right now I'm multiplying both sides. I'm multiplying the variable x by 3. So the opposite is 2 divided by 3, just like this. Make sure the whole numerator is being divided by 3. So I get x to be 4 plus or minus 2 square root of 2 divided by 3. So there's your answer. Again, if you want to rewrite it, you can say x equal 4 plus 2 square root of 2 over 3, comma, 4 minus 2 square root of 2 divided by 3. So in my math lab, they're going to ask you to rewrite it as two separate solutions separated by commas. And you could also say 4/3 plus, you could say 4/3 plus 2 square root of 2 over 3, comma, 4/3 minus 2 square root of 2 over 3. All right, so that was number 3. Number 4, suppose you had this, number 4. Suppose you had x plus 3 squared equal negative 16. So x plus 3 squared equals negative 16. All right, so again, I have some expression squared equal a number. So I'm going to take the square root of both sides, just like this. So the square root of the left side, square root of the right side. Don't forget plus and minus, though. The square and the square root undo each other. So x plus 3 equal. Now remember, we know the square root of 16 is 4. We also know that the square root of a negative 1 is I. I remember that in a previous lesson. So the square root of negative 16 then is the square root of a negative 1 times the square root of 16, so that's just 4i. Square root of 16 is 4, square root of negative 1 is I. So this becomes plus or minus 4i. And then to get the variable x by itself, just subtract 3 from both sides, combine like terms. I get x to be, now be careful, this is negative 3 plus or minus 4i. And so there's your answer. So that's in compact form. Now if on my math lab, they ask you to separate the solutions using commas, you would say negative 3 plus 4i, comma, negative 3 minus 4i. All right, number 5. Suppose you had x, let's say 3x, let me write it, 3x minus 2 squared equal, let's say, negative 5. All right, so then, again, you're gonna, it's already in that form, some expression squared equal a number. So I get 3x minus 2 squared equal negative 5. So I'm going to take the square root of both sides, plus or minus. These undo each other. So 3x minus 2 equals plus or minus. Now remember the square root of a negative 5. So remember the square root of negative 16. 16 was a perfect square. All right, so that's where I got that 4 from. Square root of a negative 1 is an imaginary unit I. Over here, though, when I rewrite this as square root of negative 1 to the square root of 5, 5 is not a perfect square, but I can rewrite square root of negative 1 as I. And remember, when you still have the radical left, leave the I in front. So I square root of 5 is what this is. So I get plus or minus I square root of 5. All right, adding 2 to both sides. Remember, you want to get the variable x by itself. Combine like terms. I get 3x equals 2 plus or minus I square root of 5. So those are two different terms. They're not alike. All right, to get a variable x by itself, right now multiplying x by 3. The opposite is to divide both sides by 3, just like this. Make sure the whole numerator is being divided by 3. Reduce, simplify, I get 3 divided by 3 is 1. 1 times x is x. And then leave it in compact form, just like this. On my math lab, if they tell you to separate the solutions, you would say 2 plus I square root of 5 divided by 3, comma, 2 minus I square root of 5 divided by 3. Okay, one more. Let's look at number 6. Suppose you had 3 times x plus 6 squared equal, let's say, 18. All right. Now, the difference between this one and all the others. So remember, in order to use the square root property, it has to look like u squared equal a number, u squared. So some expression squared equal a number. That's how it's supposed to look. And this number in front of this parentheses has to be a 1. This number in front of u squared has to be a 1. Okay? So make sure that's a 1. So when I look at this, though, this is not a 1, that's a 3. So before you take the square root of both sides, you got to make sure that's a 1. So right now I'm multiplying this expression by 3. So that's multiplication. So the opposite would be to divide both sides by 3. So the first step you had to do was to divide both sides by 3 and then simplify. 3 divided by 3 is 1. Now there's your 1. 1 times x plus 6 squared is x plus 6 squared. 18 divided by 3 is 6. So now this looks now like this. Some expression squared equal a number. And now I can take the square root of both sides. Okay, so remember that if there's a number out here, you got to make sure that's a 1, so you can divide both sides by that coefficient, by this number. Okay, so now we're going to take the square root of both sides. Plus or minus, don't forget the plus or minus. The square and the square root undo each other. So x plus 6, I'm left with this expression, x plus 6 equal plus or minus the square root of 6. 6 is not a perfect square, so there's no perfect square other than the one that goes into 6, so I cannot simplify this. So I leave it as it is. I just got to get the variable by itself, though. So I'm subtract 6 from both sides. Combine like terms. 6 subtract 6 is 0. X plus 0 is x. And then this just becomes negative 6 plus or minus square root of 6. Negative 6 plus or minus square root of 6. So there's your answer. On MATLAB, you would have to probably separate them. So you'd say negative 6 plus the square root of 6, comma, negative 6 minus the square root of 6. Okay, so that takes care of part 2. And part 2, remember, was solving quadratic equations by using the square root property.